Welcome to another video and about all my Arduino Mega2560, including some electronics and speaker continued experiment, including and involving Octave, a scientific programming language which has as a result that the Arduino is no longer non-volatile memory, so everything would be stored on the Arduino, but it is volatile memory. When I remove this USB cable, it won't work. Then a speaker, because of the Arduino package in Octave, or that can be applied to Octave, you can play tones. And there is a problem with it, because according to the manual of that specific package, you should be able to indicate how many seconds a tone plays, tone frequency. But for me, so far, that doesn't work. When I put the oscilloscope on the pattern setting, then you can clearly see the different patterns and in frequencies, but it doesn't show the number of seconds between the tones. And the last thing say that a tone lasts 3 seconds and another tone lasts 6 seconds, then you do not see the difference between the 3 and the 6 seconds. So that's a problem. Anyway, let's run the code so far. Then you get something like this. 2 tones, or a couple of tones, and that should not be this pattern. So I'm now bound to try to find out how to solve this. It's now tones that take equally as long and faster and slower, and even that doesn't make sense. So let's go to the software. Right, so with a scope set to pattern as said, let's watch again. And again it takes time for 3 seconds. And I have to keep in mind to adjust this probe, otherwise it doesn't go nice with the sound. And here the various patterns, not the lasting, but just the patterns. And yes, you see the different frequencies, but that's not what I want. So what I want to do, you hear it speed up and slow down. So another thing is that this for some reason doesn't work, but let me test. Yeah, it does work. Okay, that's good. This time it accepts 1 Z and then stops finally. But what I want to find out if it can show a different frequency for the LED. So I'm copying and pasting, and that means that I am going to double the frequency. So I should see a pattern which is well, double the frequency that is displayed here. 3 seconds, 6 seconds lasting, another 3 seconds and another 6 seconds. Will it work out? I suspect it won't. Yeah, it does. Oh, it does. The frequency does. But the time in between, because this should last 6 seconds, and that it certainly doesn't. What does is the frequency. So yes, just like here, it just like with the sound, it does show the different frequencies, but not the time in between. So how can I distinguish even more? 200, 1200 and 600. Yeah, those are the frequencies. Okay, let me explore more if I can find out what I'm doing wrong, although this is exactly copied from the manual. Well, call it the manual for this package, for the Arduino package. So something is not quite correct. Maybe I missed an example. And from the package information, this is all there is. Connected Arduino object, then digital pin to play on, frequency in hertz, and duration in seconds to play. And this refers to 3 in this case, which is here 6 seconds to play. That is not happening at all. So the big question is, why doesn't it work? There's no example provided. So I am in the dark about why it doesn't happen. Maybe I can find another working example, because I don't think somehow that I am the only one that uses this function. Anyway, let's find further. So, what to do about this? As there is no real example except for what this shows, really. Well, the only thing that is different in all those examples is that they don't use variables, apart from this one then. So what I am going to try is to change all this. Although it shouldn't matter, with the emphasis on should. But if this changes, then I basically know enough. So let's go. Yeah, right. So that really didn't change. Okay. This the silence should last 6 seconds. So if I change this, then it may be a little bit more clear. No, this should be 6 then, and this should be 3. Then I get less silence but more signal. So let's adjust the time base. It is more clear what happens, but the time in between is definitely the same. With a time is of 20 milliseconds per horizontal part. Let's say that's 6, but in between that's no good. Definitely no good. I mean, in between here should be 10 seconds. There's no way that's 10 seconds. No way this is 10 seconds. No way this is 3 seconds. They can't be the same, and yet they look the same. So frequency is different? Yes, definitely. Time? No. So what to do about it? I'm not quite sure. Let me change the rest as well. So stop tempting my ears. Then this will be 8. This will be 10. Although 10 seconds is really a long time, but since it doesn't work anyway, who cares? Then this would be 10 already. D3 is 8. D4 is 10. So if you look at how different things are, then it should take 9, 15, 18, 26, 36, 46, 54, 64. This and this is 72. So this whole function duration should take more than a minute. Instead, it lasts a few, just mere seconds. Yeah, right. Let's do something again. Yeah. So instead of, let's say, 4 seconds and not 72 seconds, what's going on? What's wrong? What is the problem here? Because you can speak of a problem, and I'm not quite sure. Alright, in an attempt to show the real execution, I have added pauses after this, after the LED play tones. Let's see what that gives. And this is something very different. Now you see the actual thing happening. This is lasting for 6 seconds. And the break lasts 3 seconds, or should last 3 seconds. So if I go to the one time-based setting, 1 second, then things become a bit clearer, although not entirely clear, because 100 Hertz should last 3 seconds, as you can see, 6 seconds, then 3 seconds. And each thing is, by my knowledge, 1 second. So that is not entirely accurate either. What is happening here? What happens if I put the same thing here? 3, then this will become 8. Even 10. Another 10. And another 8. And another 10. And yet another 8 finally. So, let's first break this off. Oh, that's nice, because will this even work? Okay. Just give it a break, literally. Then go. Now it will last really long. And this will get annoying. Over a minute. And that is what happens when you get a real, the actual time that it should last. So this would be really annoying. And this is certainly not how it does last without the pauses. Without the break. No, yeah, it's a pause, not a break. Here the LED starts again. So, totally different. And time it again, annoying. And notice the difference in frequency. Higher frequency, lower frequency. Anyway. If this is supposed to happen, then time really does not work. But how to fix it, I don't know. And with that result, I think I end this series of audio experiment. Hopefully things get better with this function, but so far, and maybe it does only work in certain environments that I don't know. But the real stuff, as I showed you with the pauses in between, gets on your nerves. So yeah, really it should get faster and faster, but for so far it was nice. Anyway, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. Show your appreciation, please, by making a donation via PayPal or Wired. You can also become a patron and have your name mentioned, depending on the pledge you make. For now, this is the end of this Arduino series. What I'm going to do is probably continue with Octave, but then again with a different part of the Arduino package. Have to find out yet. What I can also do is restore the function on the functionality on the Arduino. Who knows? Anyway, we'll see about that. For now, thanks for watching. Have a nice day and bye bye.